In this chapter, we're going to talk about sequences in series. A sequence is just a list of numbers. So what you see at the right is just a list of numbers separated by commas. That's referred to as a sequence. Each number in the sequence, the 2, the 345, the 7, or the 45, are referred to as terms. A sequence that has a common difference between consecutive terms is called an arithmetic sequence. What do I mean by common difference between consecutive terms? Well, when you look at this one here, to go from 5 to 9, you go up by 4. To go from 9 to 13, you go up by 4. To go from 13 to 17, you go up by 4. That's referred to as that common difference. Always to find your common difference, you take one term like the 17 minus the previous term, which is 13, and we would get 4. So we would say our difference is that. Now, if you always take one term minus the previous term, for no matter what terms you deal with, you always end up with the same number. It's referred to as an arithmetic sequence. Sequences may go on forever, which are called infinite sequences, or they may have a finite number of terms, meaning finite sequences. So let's go ahead and list the next 4 terms for these arithmetic sequences. You'll notice you go from -8 to -6, you have to go up by 2. From -6 to -4, you go up by 2. In other words, we're adding 2 each time. That would be our common difference. So we add 2 again, get -2. Add 2 again, we get 0. Add 2 again, we get 2. Add 2 again, we get 4. You'll notice over here, as we go along, we're going down by 3 each time. So if you go down by 3 again, you get down to 1. Go down by 3 again from this one, you get to -2. Go down by 3 again, you get to -5. Go down by 3 again, you get -8. Your formula for finding the general formula for an arithmetic sequence is this one here. You'll want to make sure you know this formula. It's going to be used throughout this whole chapter, and it will be on your final. Now the D here is referred to as that common difference that we talked about before. This A sub 1 refers to your first term, and this N refers to the position or the term that you want to find. Your -4 here is in the 3rd position because it's the 3rd number in the sequence. Your -6 is in the 2nd position, so N would be 2 for that one. So let's go ahead and find the general formula for an arithmetic sequence for each one of these problems. So I'm starting out with this. You need to substitute in your first term. Well, we know our first term is that -8. Then we want to go plus. Now, when you're trying to find the general term for an equation, you're going to leave this alone. So now we need to go ahead and find that D. Well, from what we said on the previous page, because it's the same sequence, we said we were going up by 2, so you're going to still have that n minus 1 going up by 2, so you're going to end up getting 2 for your common difference, and you just put it in there. That's the formula that we're looking for. You could leave your answer looking like this, or if you chose to go ahead and eliminate the parentheses by combining or distributing and then combining your like terms, it would simplify down to this one down here. Now, whichever one of these you choose to leave your final answer as does not make a difference. So let's do that one over here. We know our first term's a -10, so we're going to start with our formula. We're going to replace a sub 1 with our first term. Go plus. Remember, leave the parentheses alone when you're trying to find the formula. Put in your common difference, which we're going down by 3 each time, so your common difference is -3. But you need to make sure you put your -3 in parentheses, otherwise it looks like subtracting 3. At this point, you could leave it like that, or you could distribute through and then combine like terms. If you did distribute through and combine like terms, you would get this down here. The terms between any two consecutive or non-consecutive terms of an arithmetic sequence are called arithmetic means. So here, we're asked to find the three arithmetic means between 21 and 45. So that means there's going to be three numbers in between these two, so that it really ends up forming an arithmetic sequence. So what I'm going to do is I'm going to treat 21 as my first term. Since we're trying to find three arithmetic means, I'm going to leave three spaces for the three separate numbers. And then I'll put down my last one, which is the 45. So this forms an arithmetic sequence. We need to just find the terms that we are missing. Now, you notice to go from here to here, you have to add a difference. To go from here to here, you'd have to add a difference. To go from here to here, you'd have to add a difference. And to go from here to here, you'd have to add another difference. Well, you need to add 4 differences then to be able to go from 45 to 21. So a couple ways you could do this problem. You could take your 45 minus 21 and divide it by the 4 differences. So on top you get 24 divided by 4, so you end up getting 6. Another way it could be done is by going ahead and using your formula here and plugging stuff in. Now we know our first term is the 21 plus. We don't know the difference. We're trying to find that. Now, our 45 here is in the 5th position because it would be the 5th number. So I'm going to plug in 5 for n. Since I'm trying to find, or putting in n being 5 for the 5th position, I need to put the 5th term here. The 5th term would be that 45. Now we could go ahead and solve this by subtracting 21 from both sides so that we could go ahead and try to find d. And so then you get 24 is equal to 4, because that's what our parentheses simplifies down to, times d. And then we get d to be 6. So whichever way you choose to do it does not make a difference. So we know we got to go ahead and add our difference to go from here to here. So our next arithmetic mean, we'd have to add our 6 and get 27. So 27 would be our first number. So if this one's 27 then, to be able to get to the next number, you got to add your difference of 6, which is 33. So you take your second term of 27, add 6, you get 33. Then to get your last one here, you'd have to add 6 again. Or if we were up here, you add 6, you get 39. Now, one way to go ahead and double check that is if you add your 6 to this last mean, do you end up getting your 45? And the answer is yes, we do.